Hey folks, in this problem we're going to use Hess's law to determine the enthalpy for the reaction and the production of so-called coal gas. Alright, so here's our reaction. Alright, carbon plus water generates CH4, which is methane, and carbon dioxide. And that's what we're trying to determine delta H for that. So how are we going to do that? Well, in this case, we're going to use Hess's law, which means what we're going to do is find the combination of reactions that when added together will give us this reaction for the production of the so-called coal gas. So we're not using enthalpies of formation here. We're using the reactions given here, these three reactions, and the corresponding values of delta H. So we have to find the combination of these three reactions that when added together will give us the reaction for the production of coal gas. So how are we going to do that? Well, so generally what I'm going to do is I'm going to just go down the list and take a look at the reactants and products to figure out what's going on. So we'll look at the first reaction here. And we'll see we've got carbon as a reactant, but we'll notice that there are two carbons in our reaction up here for coal gas. So I'm going to start by saying, well, I need two carbons. So let's multiply that one by 2. All right, so that means we're multiplying the stoichiometric coefficients for each of the species in the reaction by 2. All right, so we're going to start there. All right, and then let's take a look at the second reaction. So in the second reaction, I'm going to look here and I see, well, I've got carbon monoxide, and I don't see that at all in my overall reaction. So hopefully that's going to cancel out. I've got H2O, all right, but that's good. That's in the reactant side of things. But then I've got CO2 as a product, and that's on the product side of things. So that one's looking pretty good. It's looking like everything here. Now H2 is not in the overall reaction, so I'm going to ignore that for now. But what I'm going to note is I've got H2O on the reactant side, all right, and I've got carbon dioxide on the product side, and that's consistent with our overall reaction. So I'm just going to leave that one as is for now. I'm not going to do anything to it. I'm not going to multiply it by anything. I'm not going to change. I'm not going to reverse it. So we're all good. All right, so now let's go to the third reaction, and I'm starting from left to right. So first thing I see the CH4, the methane. And I'll notice that that's on the product side of my overall reaction. So I'm thinking I probably want to switch that because none of the other reactions have methane in it. So I'm definitely going to need to reverse that reaction in order to get it done. It has one methane here and one methane here. So right now it doesn't look like I need to multiply by anything, but I do need to reverse the reaction. So I'm going to reverse this reaction, which is essentially the same as multiplying things by -1. All right, and I'm going to do the same thing over here. Since I multiplied the reaction by 2, I'm going to multiply my enthalpy by 2. I'm going to leave the second one unchanged, and I'm going to multiply the third one by -1 since I'm reversing the reaction. When we reverse the reaction, we change the sign on the enthalpy. All right. So let's add them together to make sure they're going to give us the overall reaction. So I'm going to write them all here again. So we've got 2 carbon plus 2 H2O goes to 2 carbon monoxide. And again, this is because I multiplied everything by 2 in that first reaction. All right, my second reaction I'm leaving as is, so I'll just go ahead and rewrite that. And my third reaction I am reversing. So I'm going to move the products over to the reactant side. So I'm going to do carbon monoxide plus 3H2 goes to methane plus water. I'm not bothering writing the phases here. It is important that you pay attention to those, but in this case, we're just going to write things out just to simplify things. All right, so let's add them all together. Okay, so we're going to add all three of these reactions. On the reactant side, I'm going to have 2 carbons plus 2 H2O plus carbon monoxide plus H2O plus carbon monoxide plus 3H2. Okay, now let's look at the product side. So on the product side, I'm going to write this down here. I'm going to have 2 carbon monoxide plus 2H2 from my first reaction. All right, and then I'm going to add from the second one CO2 plus H2. And then for my third reaction, methane and water. All right, so that's what I've got. All right, so let's take a look here and see what kinds of things cancel out. So I'm going to simplify the both sides a little bit right now, because you'll notice, for example, I've got 2 carbon monoxides here and I've got H2Os here. So let's just add them together. It'll make it easier in the end to see what cancels out and what doesn't. So I've got 3 H2Os, right? 1 plus 2 is 3, so I've got 3 H2Os. All right, and I've got 2 carbon monoxides, 1, 2. And I've got 3 H2s. Okay, so that's just combining things on the reactant side. Do the same thing on the product side. So I'm going to have 2 carbon monoxides plus 2 H2s. So I've got 2 H2s here and an H2 here, so that's 3 H2s. I've got a carbon dioxide. I've got a methane. And I've got water. So I just combined a few things. All right, so now what are we going to do? What we're going to do right now is see what we have on both sides of the reaction that we can cancel out. So the first thing I notice is I've got 2 carbon monoxides here on the reactant side and 2 on the product side, so they cancel out. All right, they essentially aren't reacting. I'm also going to note that I've got 3H2 here and 3H2 here, so they're going to cancel out. All right, and what's left over? So I've got carbon dioxide, methane, and I've got H2O, but I notice I've got 3 H2Os here and 1 H2O here. So one of them cancels out on both sides, and that's going to leave 2 H2Os for that. All right, so let's rewrite that. So now I've got 2 carbons plus 2 H2Os on the reactant side plus CO2 plus CH4 on the product side, and that's the reaction we're shooting for. So that works. So again, what we did was we took our first reaction, multiplied it by 2. We're adding to that the second reaction, which we're not changing, and then we're reversing that third reaction. So to get the overall enthalpy change, what we're going to do is we multiplied the first reaction by 2, so we're going to multiply that enthalpy change by 2. Second reaction is unchanged, so we're just going to have negative 41.2. Third reaction we reverse, so we multiply that by negative 1. and we add those together. And so what we've got is our overall reaction is delta H plus 2 times reaction 1, the enthalpy change, and that is 131.3 kilojoules, plus reaction 2, which is negative 41.2 kilojoules, plus reaction 3, which is negative 1 times 206.1, because again we reversed it, so we multiplied by negative 1, and so that's going to be negative 206.1 kilojoules. So now we just add them all together, and we get from that 15.3 kilojoules. So the overall reaction is endothermic because delta H is greater than 0. As always, let me know if you have any questions.